Hi everyone, so now let's look at the last question for 4D. Use the Stokes theorem to evaluate the line integrals of vector field where the f is given as this one and C is the triangle with the vertex. Okay, so these are the points of the vertex. So the unit vector normal is upward. So these are the information given by the questions. Okay, so let us put it in our calculations. Alright, so as usual, first of all, I would like to record the informations. So you have to, this is a question 4D. Question 4D. Okay, question 4D. So you have to evaluate the line integrals using the Stokes theorems. Okay, so you have the f given. So this is your f is a vectors. So you have the z square, okay, y square, and x. Okay, so this is your f. So C is the triangle. C stands for the curve. Okay, and this curve is in the triangle shape and with the vertex. Okay, so these are the vertices. Okay, you have 1, 0, 0. Okay, 0, 1, 0, and also 0, 0, 1. Okay, so these are the vertices. Okay, so you have to use the Stokes theorems. Okay, Stokes theorem. Okay, Stokes theorem telling you that you can solve the line integrals of the vector field. Okay, by using this equation, you have a double integrals, then you have the curl of the vector f, and then you dot product with the unit vector normal n and ds. Okay, so the sigma over here stands for the surface. Okay, stands for the surface. Okay, so meaning that you have to solve using this one. Okay, this formula. Okay, right. So now let's sketch the triangle. Okay, let's sketch a triangle according to the coordinate that was given by the questions. So you have 1, 0, 0. Okay, 1, 0, 0, 0, 1, 0, and also 0, 0, 1. Okay, so this is a triangle. Okay, it's your path. Okay, so now let's look at our Stokes theorem equations. So the first thing that you have to go through is this one. Okay, so the curl of the vector f. So let's find the curl of the vector f. So the curl of the vector f is equivalent to the cross product, right? So let's put them here. So you have I, J, and K. So del stands for this. Okay, and your f is z square, y square, and also x. Okay, so let's do the cross product. Okay, so first of all, for the I component, we have a 0 minus 0. Okay, minus the j components. So you have a 1 minus 2z. Okay, it's a j component and plus the k component. The k component is equal to 0 minus 0. Okay, k components. Okay, so in other words, you have only one equations. That is the 2z minus 1 j. Alright. Okay. So now we move on to finding the unit vector normal, and the question said that it is upward. So for the upward, you have to use these equations. Right. Okay, fx square plus fy square plus 1. Okay, so now you need to define what is your f. So f stands for the surface, okay, the 3D graph. So what we have here is this one. Okay, so this is the plane. Okay, this is a plane that we have, and we draw it based on the vertex given by the questions. Okay, so we can label the coordinate here, and I think every one of you draw these 3D graph before. If you want to produce the equations of this 3D graph, you have to use the general formula, something like this, right? Okay, so the ABC will represent the intersection point at axis X, axis Y, and also axis Z. So in other words, the equation of this 3D graph, okay, 3D graph will be X plus Y plus Z equals to 1. Okay, so this one you have to find out yourself, okay, because the question didn't give you this information. So for the 3D graph, the surface, the F will be equal to Z, which is equals to 1 minus X and Y. Okay, so in other words, your Fx will be -1, your Fy will be -1 as well. Alright, okay, so let's put it into the double integral. So you have the curl of the vector f, right, and this thing dot product with the unit vector n, and here you have the ds. Okay, so the curl of the vector f actually gives you a reading of a result of 0, 2z minus 1, 2z minus 1, 2z minus 1, and 0, because you only have the j components, right? And next one, the n, okay, the n will be 1, 1, and 1. Okay, so the bottom part over here, I'm going to cancel with the dx. Okay, so here you left the dx, right? Okay, so now is the terms to find out, okay, the dA. Okay, so you will left the 2z minus 1. Okay, so this z you could replace with the equation of the plane, which is 1 minus x minus y minus 1. Okay, so the other component, they are 0, so you have the dA here. So you need to find what is the dA. Okay, what coordinates you want to use, coordinate system you want to use for the dA. Okay, so this is a plane, so we will use the Cartesians. Okay, so we will go to the projections when we want to define the dA. So you could pick the xy projections. Okay, so you could see this thing. Okay, you could see this thing. Right, it's a triangle. Okay, so we draw this triangle. This is 1 and 1. This is x and this is y. Okay, so the equation for this will be y equals to negative x plus 1. Okay, so you can find this thing, okay, from the equation of plane as well. Okay, so in other words, okay, let's define the interval. Okay, the interval for the dx dy. So here you have a 2 minus 2x minus 2y, right, minus 1 dA. So I will pick the dy dx. Yeah, this is the vertical strips technique. So x will be from 0 to 1, and y will be from 0 until 1 minus x. Okay, 1 minus x. Okay, so we could do these integrations manually. Okay, so 2 minus 1 become 1. Okay, so 1. So you will have a 1 minus 2x. Okay, integrate with the y. Okay, integrate with respect to the y. You get this thing, 2 y squared over 2. Okay, so this one we do it manually. Oops, I'm wrong. Right, the number should put outside, am I right? Yeah, the dx. 1 minus x. Okay, so it's 1 minus x here. Okay, right. Okay, so you have a 1 minus 2x. Right, so here you have a 1 minus x. So minus 1 minus x and square dx. Okay, so now you can press your calculator for the answer. So let's try. So we have integrate 1 minus 2x, close my bracket, 1 minus x, close my bracket, minus 1 minus x squared. No, I should close my bracket first. Okay. One, 0. Let me confirm again. Minus is equals to 0.3 negative 0.37. 1, 2, 3. Let me see the answer. 1/6. No, this is not the answer. One minus oops, alright. I know where is my mistake. Yeah. So now I get the answer. Yes, the answer is correct. But why I have the negative? Let me check. 0.17. 167. So the answer is 0.167. 1 minus 2x, 1 minus 2x minus 2y square. So I get my answer is negative. So if you could tell me where is my mistake, you let me know so I could correct this one. 2z minus 1, 2z minus 1, negative negative become 1, 1, 1, and this is correct. 1 minus 2 minus 2x, 2y minus 1. So 2 minus 1, 1. 1 minus 2x, y, minus 1 minus x. 1 minus x is also correct. Right, it's okay. So I will leave my answer in this form. If you could tell me where is my mistake, you let me know. Right, so this is question 4D. So thank you, class.